Here's the situation. You and your friend want to communicate over the internet. Fundamentally, it is simple and it is called as peer-to-peer communication. Both of you have a unique internet protocol address to which you can send your data such as audio clips, images, and documents. But there is a catch. Your IP address keeps changing if you are not on a broadband or a fixed connection. And even then, a direct link is not possible. Let us understand why by taking a quick look at the structure of today's internet. The internet has global IP address pools, some of which are reserved to big corporations and institutions, and limited IPs are assigned to ISPs, which are further subdivided into ISP subnets. A small private subnet within an ISP let millions of peers communicate over the internet without any IP overlap. This private to public IP translation is facilitated by network address translators or NATs. NATs are a sort of firewall in the network. Depending upon your connection to the internet, your NAT takes a query from the subnet and forwards it to the main internet under its own IP. This removes the need of unique IP address, as now two devices can have the same IP as long as they are under different subnets controlled by different entities. This makes any device under a layer of NAT fall in a cyberspace called as private IP address domain. So let us take a look at how we currently solve this problem. The traditional way of overcoming this is through relay communication. In relay communication, there is a server called as the relay server. This server tracks the IPs of participating peers. This act is represented here by the faint gray dotted line. If you want to send a chat to your friend, you send your data to the relay server, which then relays it or forwards it to the recipient. All communication passes through the relay server, so you can say that you whisper your message to the relay server and it tells about it to your friend on the other side. All the major video conferencing services today use relay communication for their video conferences. Presenting Icefish Bitlive. Bitlive is built in such a way that you can communicate your message directly without any kind of relay involved. Like relay server, we have a tracker in Bitlive's peer-to-peer communications. It tracks your IP and tells it to the other devices participating in the conference. This process is called as handshaking. The tracker is only part of the link until the handshake is over. Once both parties have each other's public IP addresses and open ports, they can directly talk to each other. When a new device enters the conference, the Bitlive tracker will track its open ports and public IPs and will share them with others in the conference, as well as share the other device's public IPs and open ports with the new device. Bitlive tracker only acts as a facilitator for the handshake and not a relay for the entire duration of the communication. When IP of one of the participating member changes, Bitlive tracker will track its new IP and share it with other devices in the conference. In Bitlive, there is no relaying of any kind. All the data is exchanged only between the participants directly by the means of peer-to-peer communication. Now, let's take a look at what are the advantages of peer-to-peer over the existing system. When comparing peer-to-peer communication and relay side by side, we can quite easily make the first advantage of peer-to-peer communication. In peer-to-peer communication, the data transfer between two members occurs directly, hence there is no chance of a third party getting access to your data. Secondly, peer-to-peer communications use very minimum hardware on the network, hence making them very efficient and cheap to install. Lastly, as the peer-to-peer communication do not rely on any external hardware on the network and run on the user's own machine, they are always up when the users are. Peer-to-peer communications can sometimes become quite resource intensive. To counter this, we have derived the concept of load distribution. As the number of participants increases in a conference, more and more resources are required at the end host. In such a case, host can associate itself with one of the members of the same conference, which will provide resources such as bandwidth and computational power for encoding and decoding, thus becoming a load distributor. A certain percentage of peers will then be routed through the load distributor, which will also forward the data to the host. For survival of any product or service in the market, it needs a good business strategy. We are following The Uber model. If a host is unable to get a load distributor, it can request for a load distributor from Bitlive tracker. Bitlive will have a ready network of load distributor comprising of individual contractors willing to dedicate the machine resources. Depending upon the request, an ideal device from this network will be provided to the host. The host will pay for the resources used and a percentage of it will go to Bitlive. Now let us take a look at the Bitlife app. For this demo, we have arranged two Android devices. One of them is at the start of every conference, you need to go through a process of registration where you enter your name for that very conference. If you are the host of the meeting, you need to create a new room and share the unique room ID you receive with your peers. Once you receive the room ID from the host, you can simply enter it into the room ID tab and press the joint room button to join that room. Once you're in the room, you can talk with each other via either voice or chat. BitLive users get the choice to choose the output quality of their video. BitLive uses high performance Opus codec for voice transmission. Hence, you will never face any issues while talking with your peers. BitLive is a complete peer-to-peer video conferencing solution, so you don't need to worry about your talks being heard by anybody else on the internet. BitLive by Icefish is currently at technology readiness level 4, an ugly prototype. Team members are Ojas Gowde and Vivek Vaishya. Our mentor is Professor Bhagyashri Patil.